So take a look at this theorem. So let b be a real number and h is going to be a function that maps the reals to the reals be given. Then there's a unique function f that maps the natural numbers to the reals such that f of 1 is equal to b and f of n plus 1 is equal to h of f of n for all n in the natural numbers. This possibly might be the most confusing theorem you have ever seen in your mathematical careers. I could be wrong, but this is really tricky. What we're saying is that there's going to be some real number and then this function that maps the reals to the reals, but then there's also this unique function that now is only going to map the natural numbers to the real numbers. But then this function here says that 1 gets mapped to b, but then f of n plus 1 is then related to this previous function, but then that's going to be the inside of f. So nonetheless, I'm going to take a look at this example of what is this theorem stating for us. This is a really important theorem for us to understand sequences. Let's take a look at this example. So this is an example of a recursively defined sequence. A sub n plus 1 is equal to 3 plus 2 times a sub n, where a sub 1 is 4. So my starting number is 4. I find the next number by taking 4 times 2 and adding on 3, so that would get 11. I would find the next one by taking 11 times 2 and adding 3, so I would get 25, and so on and so forth. What this theorem is stating is that if we transcribe this, we're saying let b be equal to 4. So this b value is really this initial number. And h is going to still be a function that maps the reals to the reals, but the name that this function is going to be given is 3 plus 2 times x. So this recursive part of this is what we're defining the function. Then there is a unique function that maps the natural numbers to the reals such that f of 1 is 4. So we're saying the number 1 is going to be mapped to 4. And then to find the next number, the n plus 1 number, you're going to take 3 plus 2 times that number. So this is saying that there's a unique description here. So if you have your initial number and then this rule, there's only one sequence that fits that. This number plus this rule. So when we talked about how you need to properly define a sequence, you need both of these. Once you define both this initial number and this recursive part, there's only one function that makes that work, and that function is the sequence. So notation-wise, we're not discussing about f of n. We're really instead saying a sub n is the same thing as f of n. So we get the sequence we want by saying this f of n is really a sub n. So if we're talking about f of 1, so this f of 1, that's really saying a sub 1 is equal to 4. This f of n plus 1, this is really saying a sub n plus 1 is equal to 3 plus 2 times a sub n. So we're just using slightly different notation. But the reason why we're doing that is because this shows that a sequence is a function. So a sequence is a function, but it's a special function. It's a function whose domain is the natural numbers. The sequence is really this thing here, this f that we're defining this. So you normally think about functions defined on real numbers. You think about it being defined on intervals, all real numbers, intervals excluding things, whatever. But a sequence is a special type of function where the inputs are natural numbers and all natural numbers. Now I'm highlighting this especially for those who will be teaching. This is one of those facts that they expect high school math teachers to know. High school math teachers are expected to know how to teach sequences because it's just a special case of functions where you have a discrete domain. The domain is not intervals, it's discrete standalone numbers. 1 gets mapped to something, 2 gets mapped to something. So here we would see 1 gets mapped to 4, and we said f of 2, that one, we said the next number would be 11. F of 3, we see would be the next one. We said that was going to be 25. But we don't have f of 2.5 does not exist. we do not have this be defined for any non-natural number. So this is what a recursive sequence is, or this is what a general sequence is, and then this is how we can deal with the idea of recursive, with there being a unique sequence that we're looking at, that this is sufficient for us to define a sequence.